Hello everyone and welcome to this video, and we're going to be briefly exploring the idea of limits and how we can represent this in programming language in Python, very simply, just so you can visually see and you can also see the calculations being done right, because it's very hard to calculate using infinity, but computers can do that very easily for us, or they can come to a very accurate estimation very quickly for us. So let's take a look here. 1 over x. This is very simple. We're saying basically as 1 over x approaches a number, in this case it's 1000, plot that relationship on a graph. And that's what this graph is. This is what this is plotting, right? So you can see as x is 100, the y value, if you go all the way here, the y value would be something like 0.01, which is 1 over 100. Okay, and this checks out for any number on this line right here. If we made this bigger, the graph does change. Okay, it gets steeper and steeper, but as it gets to a certain number, it gets kind of ridiculous to plot, right? That's just how this relationship plots out. And because we're expanding the graph to such a large value, 10,000, that's why this graph looks so incredibly strange, because we have so many values that are really close to zero, but not actually zero. And we have so few values that are, above the 0.01 range that we get this really interesting weird L shape here. Okay, and if I put 30, a much more reasonable number, you can see that this is plotted in a way that we can understand much better visually. Okay, perfect. And actually, if we take a look at here, this is an easy example. 5 as an input. Okay, so 1 over 5, if we just hover over and go to the left-hand side, is 0.2, which checks out, right? So we can see that this is actually true. This does work. Very good. So we'll move on. Now let's take a look at using limits in our IDE, which is what I'm using in this window. So this is the code to express the limit. Okay, so we're basically saying as x approaches infinity, calculate the value of this particular limit. Okay, so we haven't printed the result yet, but if I say print result and if I say run all, you can see that the result is equal to 0, which is what I explained in the last lesson, right? And technically it isn't 0, but because we're using a limit, not an actual, really accurate calculation, that's why it says 0, because it gets closer to, but doesn't approach 0. That's what limits describe, right? Let's make this a little bit more complicated here. So here, instead of using x, we're using n. And the equation we're using here is 1 plus 1 over n, in parentheses, to the power of n. Okay, and we're going to see what this equals here. So if we print here, let's say print result. Okay, let's have a look. We get e, which is quite interesting. Okay, and e represents a constant, which is Euler's number. Okay, let's use something else. Let's use eval result. I think this should work. Let's have a look. Okay. It does not work. Okay, very good. Let's try it in a different way. Eval. There we go. Okay, very good. So now we're evaluating the actual numerical value, which is 2.71828182, so on and so forth. This is the numerical value for e. If we just take this away, this e and this number here, they are the same value. Okay, so here we've calculated using SymPy, using Python, our limits. We've tested to see that, yes, this is the visual representation of a limit for the function 1 over x. And we've also gone into a little bit of how we can express that using programming language and how programming language computes this as a value. So if we say eval f, then we get the numerical value. If we get rid of this here, we would get e, which is a constant. So hopefully that's helpful to you all. I find this very interesting. I actually really enjoy using programming language, especially Python, to calculate these types of things. I think it really solidifies what you're learning. And there's a lot of crossover between Python and programming and math. So if you are a mathematician who doesn't know how to program, you can get up to speed with what I'm doing quite easily. It's not very complicated. And I think that will help you a lot. And it's actually quite fun. So I do encourage you to try that out. Okay. Next video, we're going to be exploring derivatives. And we're going to be doing a little explanation first. And then we're going to look at the SymPy version on our IDE. Okay, so hopefully you look forward to that, and I'll see you guys in the next video.